Okay, guys, we are. Today's lecture is going to be about concentration, and this is in preparation for your homework assignment tonight. So, yes, we're streaming live, and we're recording this. This might be a faster way for me to record the videos. So we're going to start with just what is concentration. We're not talking about you thinking about your homework or thinking really hard about something. This is specifically to do with solutions. So how many of you, so if you've ever made orange juice before, you get your pitcher, you get your pitcher, right? And you have, it's kind of ugly over here on the side. And then you have your handle. Yeah, I'm not happy with that one. Your pitcher and your handle for your pitcher. Okay, and then into your, if you make orange juice, you do the from concentrate. Okay, you take your, you take your can of concentrated orange juice, and then you pour water into it. Right, so we get. So we have orange juice, right? And then you pour water into it. Okay, and so you have, and the reason you pour water into it is because you want all of these orange juice particles to spread out throughout the water. Okay, well, what if you were to put less water into it and still dissolve it all? Okay, you would still have the same number of particles, but it would be in less water, and so it would be more concentrated. And this is how I want you to think about concentration. Concentration is the amount of particles. Concentration is the amount of solute divided by the amount of solvent or solution. Okay, so it's how much solute you have divided by how much solvent or solution you have. And in particular, the one we're going to focus on is called molarity. Okay, and molarity is specifically defined as number of moles of solute divided by the number of liters of solution, or how many yeah, so it's how much stuff, how much of your solute are you dissolving in how many liters of solution. Okay, and so it's really this, this is these are units, it's moles per liter, and this idea of moles per liter has an abbreviation, and it's called M. So if you have a 2 molar, and that's what this means, molar, as in the adjective of moles, okay, it's a molar. If you have a 2 molar solution of, say, salt water, then you have 2 moles for every liter of salt water. Okay, I don't know what the molarity of orange juice is. There's a whole bunch of different stuff in there, but you can imagine the taste if you just take a scoop of this stuff. Okay, just take take that little chunk right there and eat it in a spoon and put it in your mouth. It's going to be really concentrated. Or imagine doing that with with lemon juice. Say you're making lemonade and you squeeze an actual lemon into it. If you can taste the lemon, it's really concentrated. But if you put it into, if you dissolve it in water, then it's going to, that sourness is going to dissipate, and it's not going to be as concentrated as you had before. Okay, so molarity just means that we have however many moles of our stuff. So in this case, we have our orange juice that's separated, right? So we'll make a new pitcher here. better, isn't it? All right. So now we have our water, and this is what it looks like at the particle level. So we have our molecules of water. Let's make our particles a little bigger. Right? Okay, so that's our water. And then intermixed with that, we also have our orange juice mixed in with the water. And this is what our orange juice really winds up being. But if we have so this is our regular flavor orange juice. Let's say we have a dilute orange juice. Let's say we put more water into this, but there's actually less we keep the same amount of orange juice particles, but we have more water. What's going to happen to our concentration right there? Well, if we keep the same amount of orange juice, wrong brush. All right, so here's our picture again. Except this time we have a lot more water. All right. Let's fill it up here. Okay, but our orange juice is significantly less. Okay, well actually our orange juice isn't less. We just have the same amount of orange juice that we had here, but now it's distributed throughout a much greater, throughout more solvent. So if this one was if this was 1 mole if the top one was 1 mole of orange juice, okay, in say half a liter, this would be 1 divided by 0.5. This would wind up being our 2 molar orange juice. But down here, if we have the same 1 mole of orange juice, and we put it in, and we dilute it, and we increase the amount of water we have, and now we have 1.0 liters of water. Now all of a sudden, our molarity has decreased. Just because we've added more water. Okay, and we can actually use this to make dilutions and make smaller, take a piece of this, take a chunk of this stuff right here, because we'll know if we take, like, say 10 milliliters of this, we're going to have, well, if we have 10 milliliters of 1.0 molar OJ, okay, so 10 milliliters is 0.010 liters, okay, of 1.0 molar. Well, if this is a 1-to-1, so what does of mean? You guys remember what of means? Of means multiply. So if we take our 0.01 liters, okay, and we multiply it by 1.0 molar, we're going to wind up with 0.01 moles of orange juice. But then if we put that into 1 liter, if we put that into 1.0 liters of water, then we're going to get 0.01 mole in 1.0 liters. and all of a sudden we have 0.01 molar, right? So we can keep diluting it, and we can measure how much our decrease in concentration, just how much less concentrated it is. It is difficult to become more concentrated because you have to start removing water from your solute, and we can't really do that. So that's the idea behind molarity. We're going to have some more, you guys will have some further dilution questions in the future, but right now this should be enough to get you through your assignment for today.